So we're finishing up radicals here, and it says the distance formula and circles up there, but I actually took that out. I see why they wanted to include it, but at the same time, we ain't got time. So is this the product rule, the quotient rule, simplifying radicals, blah, blah, blah. And we're going to talk about the Pythagorean theorem, which is everyone's favorite, a squared plus b squared equals c squared. The reason why we're talking about that is normally you're going to get some kind of number for here, and that's going to equal c squared, so you're going to have to take the square root of both sides. I'll go over that obviously later, but just giving you a heads up of why it's in here. And so that's why you need to know that, is you're going to take the square root of some number at some point. So now I get 15 minutes. Okay. So this just says if n is a natural number, the square root of n to the a times b. The neat thing with this is basically what this is saying is that as long as you have the same index here, you can actually multiply whatever's underneath together and join it into 1. So I think last time we talked maybe about separating them, so now this is also saying that you can join them. So for instance, if you have the square root of 5 and the square root of 13, remember that your index here is a 2, your index here is a 2, so you literally can say that this is just the square root of 65, because that's 13 times 5. Yes. Same thing with this one, because you have an index of 2, you could just say that it's the gigantic square root of 7xy. So that's all it's saying, is that you can do that. So, oh yeah. Side note, I think I left the majority of the answers on this one, just so when I upload it, if you guys want to see it or utilize it again, you can do that. So, also, quick side note is that on the quiz, I think there's more from 10.1 and 10.2 than there is 10.3. So just a heads up. Okay, so for this one, same thing. Now, all they wanted to show you here is that go ahead and take a second to work on these if you want, or what they were showing you here is that this has an index of 3 and that does too. So it works the same way that way. I'm choking on an almond. So it works the same way. You just have to have the same index. So even down here, it's still the 6th root, and then 8 times 2 is 16. R squared times r to the cube is r to the 5th. Now here, what they wanted to do is they wanted to show that this has an index of 2, this has an index of 3, so that actually can't simplify at all. You can't combine those with different indexes. Yeah, so that's all that's saying. Okay, so now talking about, that was the product rule. So basically, if you have two radicals, same index, you can join them together into 1. Same thing with the quotient rule. So if you have a quotient written like this, and this is what I like to do, where it's combined, you can also separate them. The same thing with you can combine them. So what I mean by that is if we have the square root of 100 over 81, there's 2 ways you can really solve this. What I do is I think of this as the square root of 100 over the square root of 81. Just think about them separately. The square root of 100 is 10. The square root of 100 is 9, and you're done. The other thing is if you could simplify this, you could simplify this first and then separate them, but in this case you can't simplify them first. So same thing with here. Now this is where it gets a little tricky. This one is a little advanced. I don't think I put like one of these on your homework, but I just want to walk you through it. You have the square root of 11 over the square root of 25. Well, the square root of 11 just stays the square root of 11. So what we're talking about, and we talked about this last chapter, is you have to think of your perfect squares. So 1 times 1 is 1, 2 times 2 is 2, 3 times 3 is, 2 times 2 is 4, 3 times 3 is 9, those kind of things. Here, what's the square root of 25? That's 5, so it stays just like that. And then this one, be careful, we're talking about the cube root. So if I take the cube root of negative 27, which we can do, and the cube root of 64, if I do those in my calculator, I actually get negative 3 for this one, and I get 4 for that one. So this one is a negative 3/4. So be careful on that one. That one you can do. Sorry, let me see if I can get through these quick. But okay, this is where it gets a little intense, and so I'm going to try to kind of walk you through these in hopes that you understand what's going on here. So the first thing I always do is I always write down my perfect squares. So that's 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 10 times 10, okay? So when I look at 32, I have to think of all the this is going to be the long route for this one. I have to think of all the factors of 32, okay? So 32, I think of 1 and 32. I think of 2 and 16, and I think of 4 and 8, okay? I think that's all of them, okay? So then what I do is I start with my largest number and I see, is it over here on my list? And it's not. But you'll notice that 16 is on my list right there. Okay? So what I do is I write the square root of 32 as 16 times 2. Because 16 times 2 is 32. You can also just divide 32 by 16 to get your 2. And then, going back to the product rule, break them up. What's the square root of 16? 4. The square root of 2 stays under there. So this is my answer simplified. Okay, so I'll use the next one to kind of go over that again. So 300, bam, 100 goes in there, right? So I think I can write this as 100 times 3. Okay, so that's step 1, is finding your factors. You can also just start at your list and see if any of these go in, if you want. And that's kind of what I did there. I just noticed 100 times 3 is 300, so I noticed 100 is on my list. Yes, you can keep going to 121 and stuff like that if you have bigger numbers, but we're not going to need it in this case. Simplified, square root of 100 times the square root of 3, square root of 100, so that's step 2. Square root of 100 is 10 times the square root of 3. So this is your answer. I'll give you a hint, this one can't simplify. So 35 divided by 25 is not a perfect number. 35 divided by 16, 9 doesn't go into 35, 4 doesn't go into 35, 1 does. So this is as far as you can go on that one. Coming back to this one, 32. Let's say that you recognize that 32 is really 8 times 4, right? Well, you would take the square root of 8 times the square root of 4. Well, the square root of 4 is 2, so that comes on the outside, so here. Now, this is supposed to be my answer, right there, but I have this answer. What happened was I didn't fully simplify this. So what I have to do again is I have to think of this as 2 times the square root of 4 times the square root of 2. Square root of 4 is 2 times 2 is 4, square root of 2. So what that means is that, at least the way I think about it, is if you can factor out your greatest perfect square first, then you don't have to deal with that stuff, because that's where it gets super confusing for me. So let me go through all this. So all that's written. And then finally, this is kind of the last big thing, separate these, okay? So this is the square root of 25 times the square root of p to the 7th. Let's deal with this first. What's the square root of 25? It's going to be 5. P to the 7th. Okay, my index here is a 2. I ask myself, how many 2's go into 7? Well, I would say 3. Those 3 come on the outside, and my remainder, 1, stays on the inside. Okay, so let's try that here again. So I'm going to separate them into 3 things. Oh, sorry, it's supposed to be a y. Okay, square root of 72, if I go back to my chart, I think I get 36 times 2. Okay, again, how many 2's go into 3? 1, with 1 inside. And this is just going to stay the square root of x because I can't simplify that. So this becomes 6 square root of 2, y square root of y, because remember, 2 y's go into there, and I have 1 left, and then this is the square root of x. So the neat thing is, whatever's on the outside stays on the outside. Whatever's on the inside comes to the inside, and I'm done. Okay? So again, this one's probably the hardest one. Square root of 72, simplified as 36 times 2, 6 times the square root of 2. Y cubed. 1 set of 2 can go in there, it comes on the outside. 1 stays on the inside. Square root of x just stays on the outside. Everything under square roots, so that, and that all come here. Everything on the outside, so that and that come on the outside. Okay? You might need some help with those. Pythagorean theorem is the last one. This is a squared plus b squared equals c squared. C squared. Remember, I think about it this way. I think about the right angle there shooting a little pistol and hitting this wall, and that's going to be my c squared. So in this case, it doesn't matter which one is a and which one is b. I always put the smallest one being a. I don't know, it's just what I do. And I always put the next largest one. So here I have 8 squared plus 14. Sorry, I hit the button. Plus 14 squared equals c squared. This is 64. Plus 196, if you put it in your calculator, equals c squared. So I think that is 260. sure I'm doing this right. Always have a calculator. Yes. Yes. Okay. So then, in order to, this is what I was talking about at the very, very beginning of the video. In order to get rid of this square root, I have to take the square. You have to take the square root of that side, the square root of this side. Now, this is where it gets really tricky because I don't know. I mean, I'm thinking about these. So these are my perfect squares. Okay, so I'm just going to try 4. It's probably not going to be the biggest one, but... So I'm going to say that this is 4 times 65 equals C. So that's 2 times the square root of 65, which I believe is not going to work. Because that, I mean, I think that's as far as you can go, is what I'm trying to say. Let me see what they say. Yeah! Okay. So 65. So if I look at 65, none of these can go into 65. 25 is close, but that's it. Okay, the only thing different about this one, and this is the last one we're going to do, is you have to remember that this is my C. So when I'm setting up my a squared plus b squared equals c squared, this one's even marked b, which is kind of nice. So that means that this one's equal to a. I have 4 squared plus b squared equals 6 squared. Okay, 4 squared is 16 plus b squared equals 36. B squared equals 20 after subtracting 16 there and subtracting 16 there. So then I recognize that once I take the square root, both of those, then I get b equals the square root of 4 times 5, which I can write as the square root of 4 times the square root of 5, which is really 2 times the square root of 5. So again, 20, 4 times 5, I'm just thinking of those greatest common perfect squares that go into it. Separate them. Take the square root if you can, and you're done.